Hello everyone, this is Faculty Advisor JNFF Academy. In this video, we are going to solve GATE 2024 solution which are related to aircraft structures and vibrations. Let us start with the first question. Actually, this problem is from vibration. For a single degree of freedom, spring mass damper system subjected to harmonic forcing, the part of motion that decays due to damping is known as what? Actually, this problem is spring mass damper system problem. Here they gave the external forces harmonic function. This function is nothing but f of t is equal to f naught sin omega t. Here they are giving some damping. So based on this damping, we have to select the correct option. Therefore, the net solution consists of two parts. One is homogeneous part due to the damping, and particular integral part that is due to the externally applied forcing xp. So in this question, due to damping decay, they are asking. If you look this damping, this will come like this. So the function is a transient function. The response is transient response. Based on the damping, the graph may come like this. For under damped condition, zeta is less than 1. For critically damped condition, it may decay like this. For over damped condition, it will come like this. For critical damped condition, zeta is equal to 1. For over damped condition, zeta is greater than 1. If you look all these three variations, the response is transient response. Let's move to the next question. Yeah. Which of the following option is correct? Option A. Stress strain graph for a linear elastic material is what? So here they gave one graphical representation. If you look this graph, the variation of stress versus strain is looking like a linear line. Then next thing is elastic. Elastic means the loading path and the unloading path will be same. Loading and unloading path will be same. Then we can say that the material is fully elastic. So this option is correct. Then the next option. The material properties are independent of position in a homogeneous material. As we have discussed in our strength of material first lecture, I explained about what is meant by homogeneous, what is meant by uniform, linear, elastic, all those things. So at the time I told homogeneous means the material property will not vary based on the location or position. So this option is also correct. Then next, third option. An isotropic material has infinitely many planes of material property symmetry. So at the time of three-dimensional Hooke's law for different materials, I told about isotropic. So isotropic means the material properties will be same in every direction. So that it is having infinite number of plane of material property symmetry. Say for example, you have the core material like this. You are scooping out along this direction or this direction or this direction. Whatever the direction you are taking, it will give the same Young's modulus and Poisson's ratio. The material property will not change, which means that this material is having n number of material property symmetry. So this option is also correct. Last option. The stress strain graph for a non-linear elastic material is as shown in the figure. If you look this graph, for non-linear elastic, the graphical representation should look like this. The variation is non-linear. At the same time, the loading path and unloading path should be same. But if you look this figure, it is not same. So it is non-linear plastic material. So after reaching this particular point, the path is coming like this. We have this much amount of plastic deformation. So this is not correct. A, B, C. Let us move to the next question. Yeah. The three-dimensional stress strain relationship for an isotropic material is given as like this. For isotropic material, the number of independent constant is only 2, Young's modulus and Poisson's ratio. Actually speaking, we need 3 constants, but we can able to derive one with respect to another like this. E is equal to 2g into 1 plus nu. Okay. So if you look this three-dimensional isotropic stress strain relationship, the instead of P we will be substituting 1 minus nu. For Q, nu. For R, 1 minus 2 nu by 2. You should know this three-dimensional Hooke's law for isotropic material, then only we can able to write this. Now we will apply this concept in each option. Let us take the first option, P minus Q by 2. What is P? 1 minus nu, minus Q is nu divided by 2. So 1 minus 2 nu by 2. So our first trial is itself giving correct answer. So let us select R is equal to P minus Q by 2. So if you want, you can apply the same concept for the remaining option. Let us check quickly. The second option, nu minus 1 plus nu divided by 2. So this is wrong. Similarly, P minus R. P minus R. P minus R also we have to check. 1 minus 2 nu by 2. Yeah, this will also not giving the correct answer. Then let us check the last option, R minus P. What is R? 1 minus 2 nu by 2 minus P is 1 minus nu whole divided by 2. This is also wrong. So the correct option only one is A. Next, consider the free vibration response P, Q, R and S shown in figure of a single degree of freedom spring mass damper system with the same initial conditions. For the different damping cases listed below, which one of the following option is correct? Overdamped, underdamped, critical damped and undamped. If you look this undamped, the dotted line Q, so without any decay it will oscillate. That is for undamped condition. Then for underdamped condition, after following certain oscillation it will come to rest. So the R graph represents the underdamped condition. The next, critically damped condition is it will come to the rest with shorter duration of time. So P represents critically damped condition. Yes, overdamped condition, that will take slightly higher time than the critically damped system. So we have to select the option according to this. First one, P3, Q4, R2, S1. So the option is D. Next question. Question number 20. A particle acted upon by a constant force 4I plus j minus 3k Newton is displaced from a point A with position vector I plus 2j plus 3k meter to point B with position vector 5I plus 4j plus k meter. The work done by this force is how much joule? So we should know the formula for work done in terms of vectorial representation. So F vector dot D vector. This D displacement can be written like this. The point which we have taken here is A and B. So AB is nothing but OB minus OA, position vector. Now we will substitute everything over here. So our W is equal to F vector is 4I plus j minus 3k dot product OB minus OA. So 5 minus 1, 4I, 4 minus 2, 2j, 1 minus 3 minus 2k. This is the D vector. Now we can go for a dot product. 4, 4, 16. plus 2 plus 6, 22, 24, 24 joule. So the work done by this force is 24 joule. Next question number 22. A material has Poisson's ratio nu is equal to 0.5, Young's modulus 2500 megapascal. The percentage change in volume when subjected to hydrostatic stress magnitude 10 megapascal. So this is hydrostatic condition. I told about hydrostatic condition also. Hydrostatic condition means in all the direction same stress will be applied. Compression 10 megapascal. Everywhere 10 megapascal. If you look this Poisson's ratio nu, it should not be 0.5. If it is 0.5, the compressibility will not be there. So the bulk modulus will tends to infinity. I told in class whenever your Poisson's ratio is approaching 0.5, your bulk modulus tends to infinity. You can put it in the formula E is equal to 3K into 1 minus 2 nu. If you put instead of this nu as 0.5, you will get bulk modulus is equal to infinity. Then you cannot able to compress it. Therefore, the volume change will not be there. So the percentage change in volume is 0 over here. Next, question number 26. The figure shows plots of two yield logi for isotropic material, where sigma 1 and sigma 2 are the principal stresses. Sigma y is the yield stress in uniaxial tension. Which of the following statement is or correct? So, you should know two failure theories, Tresca failure theory and von Mises failure theory to solve this problem. The criterion P represents the von Mises stress criterion. Actually, this will touch the yield point here, here, here. So, first one, the criterion P represents the von Mises criterion. Then next, criterion P represents Tresca criterion. This is wrong. Then criterion Q represents von Mises criterion. Inside irregular hexagon. This irregular hexagon represents Tresca theory, not von Mises. So this is also wrong. Criterion Q represents the Tresca failure theory or maximum shear stress failure theory. So the correct option is A and D. Question number 27. In the figure shown below, the magnitude of internal force in member BC is dash Newton. So if you look this, the joint A and B hinged joint. Now let us take the member A, C and D. A, C, D. This represents A. Here you will be having two reactions. Since it is a hinged joint, two reactions will be the vertical reaction. Let me take it as VA. Horizontal reaction, let me take it as HA. Then at point C, one member force is acting FBC. I am assuming the direction outwards. Here the force 100 Newton is acting at an angle 30 degree. Now I can resolve this into two components. This is your 100 cos 30. This is your 100 sin 30. Similarly, I can resolve this to, you check this dimension over here, 0.5, here also 0.5. Then this angle will be 45 degree. Now we can resolve this into two components. FBC sin 45 FBC cos 45. Now I am going to take moment about A. Since it is a hinged joint, so moment will be 0. Now we have to take moment about this A point. So what are all the forces will take? So this we have to consider, and this we have to consider. This no need to consider because it is acting on the line. Similarly, the point which I am considering have these two reactions. There won't be any perpendicular distance, so no need to consider. Now let us take the moment about A by taking these two forces. So force into perpendicular distance 1 meter. The force which is acting over here is 100 sin 30 into perpendicular distance is 1 meter. This will give clockwise revolution. Then FBC, this is negative because anti-clockwise direction. FBC sin 45 into 0.5. The perpendicular distance is 0.5. So 0. Now the only unknown is FBC, that we need to find it out. 100 sin 30 divided by sin 45 divided by 0.5. So 141.42. So here they are asking only one decimal. 141.4 Newton. This is the answer. Now let us move to the next question. The state of stress at a point is caused by two separate loading cases. One of them produces a pure uniaxial tension along x dash direction, and the other one produces a pure uniaxial compression along y direction as shown in figure. The sum of maximum and minimum principal stresses for the resultant state of stress caused by both the loads acting simultaneously dash Newton by mm square. In our class, I told this concept. Whenever you are applying pure shear, the arrow should be in the meeting position. Okay, so here I consider the x phases are generating anticlockwise revolution. This is how we consider in our class. So if you see the principal stresses for this particular loading, we found these two direction as tension. The transverse direction will have compression. Okay, so in this question they are giving two individual cases. They are asking us to consider simultaneously, then what will be the resultant state of stress. Okay, so if you consider, it will go for a pure shear condition, so straight away you can put 0. This already we discussed in class. Okay, because these two are same magnitude, but the direction wise it is different. Okay, so for pure shear condition it will come like this. If suppose if you are considering the x phase is generating clockwise rotation like this, your stress direction will be compression along this direction and tension along this direction. So based on that you have to select the option. Okay, let's move to the next question. Question number 41. The cross section of a thin walled beam with a uniform wall thickness T shown in figure is subjected to a bending moment mx is equal to 10 Newton meter. If h is equal to 1 meter and T is equal to 0.001 meter, the magnitude of maximum normal stress in the cross section is dash Newton by meter square. Okay, So here the question is thin-walled section. The thickness is very very small when compared to other direction dimension. So if you go for t cube, this will be very very less than 1. Okay, so t cube has to be neglected over here. First, you need to know the formula for normal stress first. Okay, so sigma is equal to my by I. Okay, the section is symmetrical about x axis. The moment which they are applying is moment about x axis, so suffix x. So we have to consider the moment of inertia about x axis. Okay, so the y is nothing but the topmost layer from the central axis. Okay, then only we will get the maximum stress value. At extreme fibers only we will be getting the extreme stress values. Okay, so here we need to find out the Ixx first. For finding Ixx, I have to consider the section 1, section 2 and section 3. Okay, the general formula for the moment of inertia is BD cube by 12 plus A h bar square. This h bar is nothing but the distance between the global centroid with the local centroid. Okay, so first let me take the middle portion or the web portion. Okay, so here B, our B is T and h cube by 12. Okay, then area ht I have to consider. If you look this centroid of the web, this will be coinciding with the central axis of the cross section. Okay, so there won't be any y distance, so I have to put 0, then I can neglect it. Then I can consider the flange. For flange, what should I do? BD cube I have to put, right, plus B, D cube is thickness cube, plus the area is h by 2 into T, and the distance from the global centroid to the local centroid is h by 2, h by 2 square. This is our h bar. Okay, so if I consider the third flange, third section or bottom flange, I will get the same thing. Only thing is here I will get negative sign, but we have square, so this won't create any problem. So I can put 2 times over here. I can put 2 times over here. Okay, if you look this expression, here we have t cube. As I told earlier, t cube is very very less than 1, so I can neglect this. If you simplify, we can get the moment of inertia about x axis. Ixx is equal to t h cube by 12 plus 2 times of h by 2 into T h square by 4. Now we can simplify. Ixx is equal to T h cube, we can take it outside, it is a common value, 1 by 12 plus 1 by 4. So now we have to take LCM. So after simplifying, our final expression, so 4 by 12 will come, so 1 by 3. Okay, so T h cube by 3. This is the moment of inertia. Once we find the moment of inertia, then we can put it in the formula. Sigma is equal to mx. So the m value is 10 Newton meter and the y value is h by 2, so half meter. You should check all the dimensions whether all are in same unit or not. Okay, then moment of inertia Ixx, T 0.001 h cube divided by 3. Now we can simplify this. 10 into 0.5 divided by 0.001 into 3. So 15,000 Newton by meter square. 15,000 Newton by meter square. Now let us move to the next question. Question number 45. The equation of motion for a 2 degree of freedom undamped spring mass system. So they gave two equations where m and k represents mass and stiffness in corresponding SI units. x1, x2 are the degree of freedom. The larger of two natural frequencies given by omega is equal to alpha times of root of k by m. The value of alpha is equal to how much? Okay. So this is 2 degree of freedom system. Actually speaking, we have to write this in a matrix form like this: m 0 0 m x1 double dot x2 double dot plus stiffness matrix 2k minus k 2k and x1 x2 is equal to 0 0. This is your mass matrix, this is your stiffness matrix. So in our class what we have done is we consider x1 is equal to capital X1 sin omega t, x2 is equal to capital X2 or A2 we consider sin omega t, and we substituted these two things in the above equation. Okay, so we have done 2 times derivative of this, and we substituted over here. At the same time we substituted over here. After substituting everything, we will arrange this in this format: k minus m omega square determinant is equal to 0. Okay, so for time being I am skipping the step, so straight away I will go for this step: k minus m omega square. Okay, so instead of k, here we have 2 times of k minus m omega square, here minus k, here minus k, 2k minus m omega square is equal to 0. 2k minus m omega square, so triple minus will come, so minus k square is equal to 0. A minus b whole square I need to write. 4k square plus m square omega 4 minus 4k m omega square minus k square is equal to 0. Now we will write in order wise: m square omega power 4 minus 4km by omega square plus 3k square is equal to 0. Now we can divide all the terms by m square. So our equation will look like this: omega power 4 4km by omega square by m square, here I can cancel 1m, plus 3k square by m square is equal to 0. Now I can consider p is equal to omega square. I can consider like this. So the above expression can be written like this: p square minus 4k by m p plus 3k square by m square. So this equation is looking like a quadratic equation. So the coefficient of p square is taken as a, and this coefficient is taken as b, and this constant is taken as c. Now we can write the formula: p is equal to minus b plus or minus root of b square minus 4ac by 2a. So we will write everything in this format. Already one minus is there, so plus 4k by m plus or minus b square. So straight away we will write 16 k square by m square minus 4ac. A is 1, c is 3 k square by m square divided by 2 times of a. Okay. Now we can simplify this. We don't have space. Okay, let me write it here. 4k by m plus or minus. So here 60 time is there, here 12 time is there. Remaining 4. So under the root is there, right? So 4 means 2. K square is there. So I can take k. M square I can take m. Whole divided by 2. Now we can write two things. 2k by m plus or minus k by m. After simplifying we will get like this. Okay. So first omega 1 I want. Omega 1 I want. So I will take the positive. 3k will come, right? So I have to consider everything under the root because I assumed omega square as p. Okay. So if I take positive 3k by m, then omega 2 is 2 minus 1. Okay. So k by m, root of k by m. So in our question they asked to find out the larger value. Okay. Out of these two natural frequency they are asking the larger value, that too in 2 decimal I think, right? Yeah, 2 decimal places. So we will take this, our omega 1 is equal to root 3. Root 3 means 1.732 times of k by m. So this is our alpha value, 1.732. Alpha value is 1.732. Let us move to the next question. Question number 47. Consider the plane strain field given by epsilon xx 10x y square, epsilon yy minus 5x square y, gamma xy, a xy into 2x minus y. A is a constant, gamma xy is the engineering shear strain. The value of the constant A for the strain field to be compatible is what? So for solving this problem we need to know the compatibility equation, strain compatibility equation. Okay. The expression which they gave is xy plane. So you have to consider this equation, dou square epsilon xx dou square y plus dou square epsilon yy divided by dou x square is equal to dou square gamma xy dou x dou y. Okay. Now we will find out the second derivative of each strain and we will try to find out the unknown constant. Okay. First, dou epsilon xx by dou y. This term has to be differentiated one time with respect to y. 10x into 2y. 10x into 2y. So straight away we can write 20xy. Then second derivative with respect to y, 20x. Then we will go for the next term, epsilon yy. So dou epsilon yy divided by dou x minus 10 xy, dou square epsilon yy dou x square is equal to minus 10y. Next we will do the same for gamma xy. Dou gamma xy with respect to dou y. So we will get, before that we will expand this, a x square y minus ax y square. 2a x square y minus ax y square. Okay. Now we will do the differentiation with respect to y. Yeah. 2a x square y minus ax y square. At the first place 2a x square term will come minus 2a x y will come. Next, dou square gamma xy by dou x dou y. This time I need to differentiate with respect to x. Therefore 4a x minus 2a y. 2a y. Now we will substitute everything in this equation. Here what we got? 20 times of x. Then for the second place we got minus 10 times is equal to 4 a, we can take it outside, 2y. Okay, now we can go for the coefficient on both sides. You can equate the coefficients on both sides. Okay, 20 times of x is equal to 4ax. X we can cancel, a is 5 times. So the unknown constant a is 5. Thank you for watching this video. To learn more about these type of concepts, please join with JNFF Academy. Thank you.